Scientists have just discovered a promising new planet, which is Earth-sized, located very close to our solar system and capable of providing a favorable environment for life as we know it. This planet is named Gliese 12b, orbiting a small, cool red dwarf star located about 45 light-years from Earth.
It was discovered by NASA's Transiting Exoplanet Survey Satellite, TESS, with an estimated size of 1.1 times that of Earth, making it similar to Earth and Venus. To date, TESS has found over 440 exoplanets. Gliese 12b is among a group of large Earth-sized exoplanets with temperate temperatures, close enough to study their atmospheres in detail. The planet Gliese 12b orbits its host star Gliese 12 at a very close distance, making its year equivalent to just 12.8 Earth days.
However, because the red dwarf Gliese 12 is only about a quarter the size of the Sun, it is also much cooler than our star. This means that, although Gliese 12b is only about 7% of the distance from its star as Earth is from the Sun, it still lies within the habitable zone of this planetary system.
This zone is also known as the Goldilocks zone, the area around a star that is neither too hot nor too cold for planets that potentially hold liquid water, a key ingredient for life as we know it.
However, researchers are still uncertain whether it has an atmosphere. Therefore, we still do not know for sure if this planet is habitable, but researchers are cautiously optimistic.
The most exciting thing is that this planet is really close. In fact, it is one of the closest planets to Earth.
Scientist Larissa Peltier from the University of London shared with Svej.com that it lies in the habitable zone of the star right on its edge, so it could be habitable. Scientists detected Gliese 12b when it transited or passed in front of its host star.
This transit causes small bits in light that TESS is very good at detecting. When the research team joined this project, they did not know for sure what the orbital period or size of the planet would be.
Larissa Peltier said that so far, only a few exoplanets are suitable candidates for having liquid water. And discovering one with a size similar to Earth is quite surprising. So, it's really amazing to be able to identify it. But I particularly think that, in terms of habitability, it being between Earth and Venus is really interesting.
Gliese 12b receives about 85% of the radiation that Venus receives from the Sun, but is thought to have a much cooler surface temperature, around 42 degrees Celsius compared to Venus's surface temperature of 464 degrees Celsius.
What this planet will teach us is to reveal what happened during the formation of Earth and Venus, so that one planet became habitable, but the other did not. It could help us understand the proper developmental path for life that planets undergo during formation. The research team will investigate whether Gliese has an atmosphere. But initial signs suggest that if it does, that atmosphere would be relatively thin. However, perhaps surprisingly, the lack of a thick atmosphere is actually good news for the planet's habitability.
According to researcher Vincent Van Allen speaking to Translate.com,
we know some planets have thick hydrogen atmospheres covering the entire planet.
This thick hydrogen atmosphere is really bad news for habitability.
Typically, these planets are 2 to 3 times the size of Earth. Gliese 12b has the actual size of Earth, so it might not have too thick an atmosphere or it might have no atmosphere at all. This is not good for life, or it could have a thin atmosphere like Earth's. However, even if Gliese 12b has no atmosphere, it could still be an important test subject to advance the search for life elsewhere in the galaxy. That's because, as a red dwarf,
the star it orbits is the most common type of star in our galaxy. But it is the type of star about whose planetary systems we know relatively little. In the galaxy, red dwarfs make up the majority of stars that are still fusing hydrogen into helium in their cores, a process that defines the lifespan of a main sequence star.
Estimates suggest that 60% to 70% of the stars in our galaxy are red dwarfs like Gliese 12. And among the 30 closest stars to Earth, at least 20 are red dwarfs. Van Allen added, "It's exciting to learn about planets around small stars, what they are like and whether such planets could host life." officially known as K-type or M-type stars.
Red dwarfs have between 7.5% and 50% of the Sun's mass.
This low mass compared to the Sun means such stars burn at lower temperatures,
reaching only about 3,500 degrees Celsius compared to our star's temperature of 5,500 degrees. For example, the star Gliese 12 has a surface temperature of only about 60% at the Sun.
This lower temperature means that faint red dwarf stars can exist much longer in the main sequence stage, compared to medium-mass stars like the Sun.
Although the Sun is expected to last about 10 billion years, the lifespan of red dwarfs is predicted to be tens,
even hundreds of times longer. Sometimes, this number can reach trillions of years. This means that life would have more time to develop on planets orbiting red dwarfs,
compared to planets orbiting larger main sequence stars.
However, not all is good news for the possibility of life on planets orbiting red dwarfs.
An important factor for a planet to maintain an atmosphere is the activity level of its host star.
Although cooler than the Sun in their mature stage, red dwarfs are considered much more aggressive than our star.
This type of star is believed to have very strong magnetic activity, frequently emitting high-energy light bursts in the form of ultraviolet rays. This ultraviolet radiation can violently strip away the atmosphere of a planet close to a red dwarf.
In addition, recent studies show that even red dwarfs stable for many years
can suddenly erupt with supermagnetic storms 100 to 1,000 times stronger than solar storms. These eruptions are more common in the early stages of this star type, and have the potential to strip atmospheres and evaporate liquid water even in habitable zones.
However,
Gliese 12 is not so active, thus increasing the possibility that Gliese 12b's atmosphere remains intact. The fact that red dwarfs are cooler means their habitable zones are closer to the star,
actually makes detecting planets around them slightly easier for techniques
and transit methods for planet searching.
Beltop said, "Basically, we tend to detect planets close to their host stars,
simply because they transit more frequently.
When we find planets orbiting red dwarfs, because they are smaller stars, the transit depth will be greater."
But even if Gliese 12b is confirmed to be habitable for humans, and is relatively close to our star system astronomically,
the possibility of humans moving here with current technology remains impossible.